Hey, good afternoon, YouTube. Sanjeev Rajaram here. I know very many of you are interested in exercise, and I myself am very involved in exercise. I'll work out pretty much every day, either with lifting, running, or playing some sport, or I try to do it as much as possible. So today I'll be presenting a case on BPM and heart rate, and the difference in those categories for anaerobic exercise versus aerobic exercise. So let's begin. Now, anaerobic exercise is a workout that is intense and requires much effort. It's often quite short because the body is unable to meet its oxygen needs, and short as a relative term, obviously. So the body is unable to meet its oxygen needs to a satisfactory level and produces lactic acid as a result. It's usually fueled purely on glycogen, and it will increase your metabolism hours after the workout, which will allow fat cells to be continually burned. This is a great positive to that. An example of an anaerobic pathway workout would be weightlifting. Now let's talk aerobic. So the aerobic pathway is characterized as long periods of moderate exertion that allow the body to meet its oxygen needs in conjunction with the heavy output of carbon dioxide from the lungs. It's fueled by glycogen and fat, and it increases your metabolism, but not as much as an anaerobic exercise. An example would be high interval intensity training, like sprinting and jogging, or, as you can see in the picture, a bike ride. That's me do in a bikeathon back in September. So I did 2 experiments to test the heart rate and the BPM, or breaths per minute, for both these exercises. For experiment 1, my null hypothesis was that the pulse rates for an anaerobic or bodyweight lifting and aerobic or quick sprinting with jogging exercises will be the same. My alternate hypothesis is that the pulse rates for the aerobic will be greater than the anaerobic by a significant amount. Similarly, for my experiment 2, I thought the BPM for aerobic and anaerobic will be the same as my null hypotheses, and alternatively, I would say that the BPM for aerobic would be much greater than the anaerobic. So, data collection for both experiments were done at Rowan University, my alma mater, and all collected data was gathered from Rowan University students who were working out in the rec center at the time. I went into group fitness classes. People in the weight room and people on the track were all subjects of the experiment. So for the heart rate experiment, I would have my subject orient their palm upwards. I use my index and middle finger to locate the groove between their radial bone and the tendon parallel to the radial bone, which is where the radial artery is situated. And then I would count the amount of beats in 30 seconds and multiply the value by a factor of 2 to get their heart rate. For BPM, I used the stopwatch to count out 1 minute and the amount of breaths that a subject took in this time. I performed a 2-sample t-test of the data, but before that I had to check the normality. So for heart rate increase, the normality conditions are met when I set the p-value at 0.25. The curve looks good, and all the goodness of fit tests check out well. For average BPM difference, we assume normality due to the p-value, and likewise the curves and graphs all seem to check out as well. So this data seems fine. But the 2-sample t-test I used of BPM and of HR displayed a p-value which was less than the alpha value of 0.05. Therefore, I must reject my null hypothesis for both experiments. Since we can now deem the alternative hypothesis to be correct, this is suggestive of the fact that anaerobic exercise is overall the better type of workout. But there are unique benefits that emerge from both forms of exercise, which stem from the different types of workouts that are done. The benefits of anaerobic exercise increase metabolism, while aerobic exercise is used for fat burning and to metabolize sugars and lipids that remain undigested in the body. So they go great together. Performing both types of exercise routinely will give you the best of both worlds rather than just only focusing on one type. Now, here are the sources I used for this study. And I thank you today for watching my video. I hope you enjoyed it. I hope it was informative, and have a nice day.